we have gotten velocity, right? Velocity is displacement over what? Over time. So now, but if you do much practice on your own, if you are doing practice on your own, then there are some things that you don't need to be breaking down due to the fact that you have been doing more practice on your own because of your Jamb. For example, this acceleration, you should know the acceleration, the unit of acceleration is what? Meter per second. So you can easily convert it to dimension, right? When you say acceleration is equal to meter per what? Second square. Abi? What is the dimension of meter here? Dimension of meter. The dimension of meter is what? Length. Abi? That will be n per. Dimension for seconds is what? Time. T square. So you see it now? So it means that by the time you are doing your own practice at home, you don't need to undergo much stress. But why I just did this kind of breakdown? Because of the novice we have here in our midst. So now let's now see we have that displacement is what? Is L. Displacement and distance are the same thing when it comes to units. Are you getting me now? Yes. Over time is what? T, which we have it as L per T. That's above velocity for us. So when they ask you now in your exam, what is the dimension for velocity? Is what? Length per what? T. Am I communicating now? So now we'll now take it now. Come back to your acceleration. Are you getting me now? Come back to your what? To your acceleration. So now what is your acceleration? Mind you, here with acceleration is what?
Velocity over time.
Acceleration is velocity over time. Now we can re-say it that acceleration is velocity divided by time, isn't it?
Yes.
What is velocity? Velocity, we've gotten it now, is L over T. So we have L over T divided by Abi?
Yes.
Over. Now what is our time now? Time is there is what? Is T now? No, we are taking dimension. Time there is what? Is T. And should be divided by time, right? That will be divided by T. So change your division to multiplication. That will be acceleration is equal to L over T times 1 over what? T. Am I complicating now?
Yes.
Then acceleration is equal to L over T squared, right? So which we have L per T squared. Am I complicating now?
Yes.
Another way you can write it, you can also write it as LT raised to minus 2. I've explained this concept to us very well. So now we've gotten what? Acceleration, right? Then let's go back to force. So in case they ask you what is the dimension for acceleration, you can solve it for them. See the solving here. So now let's go back to what? To force. Now we say force is equals to what? Mass, right? What is the dimension for mass there? M. That is M times. Now we've already gotten acceleration, right?
Yes.
And acceleration is what? L over T squared, right?
Yes.
So that will be times L over T squared. So that will give us ml over T squared. That will be what? ml minus 2, right? So in case you see it in your Jamb that what is the dimension for force is what you have. It's more like breaking them down. Now let's now see dimension for pressure. Let's see dimension for pressure. So pressure now, we say pressure is what? Pressure is force over what? Area, right? Now we've solved for force before, right?
Yes.
What is force? Ml over what? T squared. So we have force, which is and that is equals to M. Force is what? Ml over T squared. This is divide, right?
Yes.
Divided by what? Then we have what there? Our area, right?
Yes.
And don't forget, area, dimension of area is what? L, Abi?
Yes.
But that should be L squared, right? It should be L squared now. Area is length and it's length now.
Yes.
Isn't it?
Yes.
So that will be divided by L squared, right? So change your division to what? Multiplication. That will be ml over T squared times 1 over L squared. Am I communicating?
Yes.
So we have one L at the up, we divide the other L at the down. You know, it's remaining one L, right?
Yes.
So finally, we have M over what? C squared times 1 over M. So if you multiply M times 1, M. C squared times M over M C squared. So finally, the dimension for pressure will now give us what? M L minus 1. You know it's added down now. Then C. Are you getting me now? So this is what dimension for what? Pressure. Are you getting me now? So basically, if they ask you what is the dimension for momentum, what you just have to do is very simple. Know the formula for momentum. What is the formula for momentum? Mass times what? Oh yeah, let's just do that one in this small space here. Momentum. Momentum is equal to what? Mass times what?
Velocity.
Times velocity, right? Isn't it? What is our mass? Mass is M times, now I told us, I said, you can easily use your units. You can return your units back to dimension, right? So what is the unit of velocity? Meter per seconds, right? You say your unit of velocity is, equal to what? Meter per seconds. Meter here, for the under the units, meter here, trace it here, we have what? L. Then we have this L per what? Seconds is what? C, right?
Yes.
So it basically means that this is what? L over T, isn't it?
Yes.
So if you have here, velocity is L over what? T, which gives us ML over what? T, or MLC
Minus 1.
raised by what?
Minus
1. Am I communicating now?
Yes.
Yeah, thank you. That's it.